Alright, hello everyone. So welcome to my sequences visualization video series. So in this video series, I'm going to show you convergence and divergence of a sequence using graphs, okay? And I'm going to do it for a bunch of sequences in upcoming video series. Now in this particular video, I'm only going to do that for very simple sequences, but I will discuss some important concepts at the end of the video too, okay? Alright, so this is one small step towards a big goal. In upcoming complicated mathematical concepts, I will show you the graphs and hopefully it will help you to understand the material better. Okay, so let's go down and get on with it. Now I have chosen the easiest sequence here, 1 over n, and let me show you how the code works. So here the sequence is 1 over n, and here's the list of the terms of the sequence: 1, 1/2, 1/3, so and so on. And if we plot the terms of this sequence, you can see the terms of the sequence are decreasing, right? It seems to be like they are approaching towards something. So these are the each term of the sequence, these dots. You can see they are getting smaller and smaller. The next graph, what this helps us to do is it's going to show you lots of terms in this sequence. So for example, let me increase the number of terms of this sequence. So look at the y-axis. The values are getting smaller and smaller. Now it's 0.05, 0.002, 0.001, and 0.005. So you can see the y values are getting smaller and smaller. The values of the sequence terms are getting smaller and smaller, right? And we know they should go to 0. You can see they are approaching to 0. So if you calculate the limit using Mathematica, actually the limit is 0. So it's something that we know. So this is a convergence sequence. Okay. All right. Now let's look at a different class of sequences. So for example, an is equal to r to the n. So r is a real number. So let's discuss the case when r is greater than 1, a number greater than 1. For example, let's think about the sequence 3 to the n. Now think about what happens here. So while I'm typing the think whether it's a convergent or divergent sequence. So 3 to the n. So if you plot the terms of the sequence, we get 3, 9, 27, 81. They are getting huge, right? See, the 10th term is 59,049. So it's increasing rapidly. Terms of the sequence are increasing very, very rapidly. And even look at the difference between the terms of the sequence. It is also increasing. Let's call it the jump. So from 3 to 9, it's a jump of 6. 9 to 27, it's a jump of 18. 27 to 81, it's a jump of what, 53, 50 something. So it's also increasing, right? So as you can see, the jump is also increasing. The terms of the sequence are increasing in a rapid manner. Now let's plot it. Now you would think, well, by looking at the graph, we can say that it's going to approach something in this part, right? No, it's not. The reason is this graph is tricky. Look at the y values. Look at the term of this sequence. The starting one is like 2 times 10 to the power 39. That's a huge number. So what happens here is that it's hiding bunch of large number of terms in this sequence. It's starting from a very high number, of course, because the values of this sequence are getting really huge. So let's change the plot range, okay? So let's change it from 0 to 50,000. Now you can see, look at the behavior. It's an exponential behavior, right? The values of this sequence are exponentially increasing. So it's not going to approach towards something. Look at the limit. So let's look at the limit here. Limit is infinity. Okay. So this is a divergent sequence. Okay. All right. So now think about then the sequence 2 to the power n. What do you think what happens? Well, terms of the sequence 2, 4, 8, 16, 32. Again, it's going to go to infinity, right? The terms of the sequence are getting higher and higher, getting doubled each time. Look at the jump. Here it's a jump of 2, here jump of 4, here jump of 8. Here jump of 16, jump also getting doubled. So this is also going to diverge, right? So we can come up with a general idea. We can say generally that when r is greater than 1, a sequence of this type is going to diverge. All right, now let's think when r is less than 1 but greater than 0. So for example, let's say 1/3 to the power n sequence. So 1/3 is greater than 0 but less than 1. So what do you think what happens now? Okay, let's change it a little bit. So 1/3 to the power n. Okay, all right. Okay, let's see. Now if you look at the terms of the sequence, they are getting smaller and smaller, right? See? Okay, so let's look at the graph. Now if you look at, oh, the plot range is too high. Okay, because we do not have this much higher numbers in the terms of the sequence. Okay, so now you can see they are now, it seems to be like again they are approaching towards something, but is it the case here? Let's discuss. So look at the y values. Now they are really small. Okay, 10 to the power negative 9. That's like 0.8 zeros and 1. That's really small, really close to 0, right? So here now you would think, well, these values are going to go to negative infinity. Is that the case? No, the values of the sequence are not going to get negative, right? Because n is positive, 1/3 is positive, so lowest it can go is 0. So actually the values of the terms of the sequence are approaching towards 0, right? You can see the values of the sequence are getting close to 0. So what happens is here, what do you think? What is the limit? Limit is going to be 0, as you can see here. Okay, so limit is 0. So that's what happens in this sequence. So the limit is 0, so this is a convergence sequence. So we can come up with a general criteria where r is greater, when r is greater than 1, this type of a sequence is divergent. But when r is less than 1 but greater than 0, then it's a convergent sequence. In fact, this will be convergent for absolute value of r less than 1. That means even r is greater than -1 and less than 1. Okay, perfect. Now I'm gonna touch on an important topic. Now what is the difference here really? So in the first case, we know the terms of the sequence are increasing, but in the second case, the values of the terms of the sequence are decreasing, right? So here's the question. Does that means whenever you have increasing terms in the sequence is always going to diverge? Is that a statement that we can have as a rule of thumb? Let's find out. Let me show you a sequence. Think about it, okay? 1 minus 1 over n. All right, let's look at the terms of this sequence. All right, so now here the values are increasing, okay? So it's an increasing sequence, 0, 0.5, 0.6, 0.7, 0.8, it's increasing. Okay, let's look at the graph. Oh, now the terms of the sequence, yes, they are increasing, but it seems to be like the rate that it is increasing dropped out and it's not going beyond 1, right? It's approaching towards 1, right? Seems to be like, let's draw many terms of this sequence. So let's keep increasing the terms of this sequence. You can see it does not go beyond 1. Okay, above 1. I am drawing here like 10,000 terms of this sequence and it's not going beyond 1. So even though it's increasing, it's approaching 1. See, the limit is 1. Okay, so this is a convergent sequence. It's approaching towards a real number, which is 1. So even though the terms of the sequence are increasing, it's a convergent sequence. Okay, what happens here? What's the difference here? The thing is that look at the jump. Now from first term to second term, the jump is 0.5. So from second term to third term, the jump is like 0.1. From third term to fourth term, the jump is 0.9. So the jump is decreasing. The difference between the terms of the sequence are decreasing. Okay, so the increasing rate is decreasing. You can see it from the picture too, right? So now it is 0.9 at the 10th term. So let's look at 100 terms values. You can see they are circling around 0.9 and you can see the 100th term is 0.99, 0.898 to 0.99. So the jump is really small. So the values of the sequence are getting closer to 1. So this is a convergent sequence. So the important thing is having increase in terms in the sequence does not guarantee the divergence. Okay, it depends on the situation. All right. Okay, so we will see more interesting sequences in upcoming videos. Okay, this is just a start. See you in upcoming videos. Thank you very much. Bye bye.